Higher dimensions are a common concept in math and physics. However, we perceive only three spatial dimensions. Manicone is an experiment into exploring the fourth spatial dimension by creating a four-dimensional humanoid form. An analytical construction of the human figure via geometrical workarounds has been an endeavor since the beginning of figurative representation. Laws of proportions, volume forms, spatial temporal relations, etc. are still important subjects in nowadays artistic and scientific studies of the human body. For our construction of Manicone, we were notably inspired by the Cubists and the Renaissance artists. In particular, the approximation of a human body via a skeleton and geometrical primitives like cones, spheres, and cylinders are the basis for our construction. Cones, spheres, and cylinders are mathematically seen three-dimensional analogues of so-called conic sections like a circle and a parabola. This means they are geometrical objects called quadrics, which one obtains by cutting a four-dimensional cone. Likewise, one can reverse this process of cutting into a process of extending, in the same way as one obtains a two-dimensional rectangle by sweeping out with edges, or a three-dimensional cube by sweeping out with planes. One can reconstruct four-dimensional quadrics by sweeping out within the mathematical framework. We used this extension and the skeleton for constructing Manicone. So this is our application. Here you see the cones, spheres, and ellipsoids. And if you follow the mouse, you see the skeleton. So altogether, this looks like a 3D virtual Manicone, which is actually visualized in a Java application program called JReality. However, our Manicone is a four-dimensional Manicone. But since we can't perceive four dimensions, we have to slice the four-dimensional space into three-dimensional slices. These three-dimensional slices are also called three-dimensional hyperplanes. So what you see here is basically the cut between the Manicone in four-dimensional space and the three-dimensional hyperplane, which is a three-dimensional object. And this three-dimensional object can now be deformed in three-dimensional space, in this three-dimensional hyperplane. That is what we are doing right now. That means any deformation in this three-dimensional hyperplane can be performed by dragging over the elements. So this is what we are doing right now. We are dragging the ellipsoid, which belongs to the foot, and likewise we can rotate Manicone within this three-dimensional slice. And then again we can manipulate the form as desired. However, what looks like a deformation of a three-dimensional Manicone is in reality a four-dimensional deformation. The dynamical construction behind this dragging is a discrete tractrix construction, which carries through the four-dimensional space. So this means if we tear or if we drag the Manicone in this three-dimensional subspace, then we drag also in the four-dimensional space. Or in other words, all the quadrics which you see here, like this cone here, are in fact four-dimensional quadrics, and you see just their three-dimensional cut. And they're aligned in four-dimensional space. So if I drag, I change also this alignment of these four-dimensional quadrics. Okay, but what we perceived so far is just a three-dimensional virtual space. Now let's go to the fourth dimension. On the upper left there is a toolbar. There are four sliders. The mouse button is just pointing on them, and they are giving the parameter values of a normal vector, that means a vector which is perpendicular to the three-dimensional hyperplane. So the position was just 1, 0, 0. Now I altered the second component, and as you can see, we have a new three-dimensional cut of Manicone. And again, we can manipulate or deform this mannequin in the old way by just dragging. So the quadrics you see are the slices I get by cutting with a three-dimensional new hyperplane. What we kept is the skeleton. So the skeleton is the old skeleton in the 100 hyperplane. We kept this as a reference, so in order to make the 4 dimensions more visible or more perceivable. So now the mouse pointer is again at the slider, and we move around in the 4th dimension. Now we are again in the 3-dimensional hyperplane, and we are rotating, and there's also the possibility to give the rotation a kick. So this is now a very fast kick. It's very fastly rotating, and in fact if you don't push that hard, then it's slowly. We will see this in the end. And again, the mouse button is at the slider. We can watch what's happening if we move the slider around and what's happening to the rotating 4-dimensional mannequin. Okay, so let's stop this. So we are now in an arbitrary 3-dimensional hyperplane given by the 4 sliders, the 4 top sliders. Again, we can move around and do all the manipulations as before, but we can also reset the whole figure by pushing this bar. So now we are back at the old view at the 1000 hyperplane. And there's still one more slider, which is where the mouse button is right now. And this slider is actually for changing the triangulation of the mannequin. So if I pull the slider to the left, then the figure gets even more edgy. However, if we pull the slider again to the right, then we can observe how the figure will get smooth again. So let's do this. This feature of smoothness or edginess of triangulation, or in mathematical terms, the discretization of the figure, is a little reminiscent to the cubists. However, also if this may look a little bit cubistic, we didn't intend to play around with forms like the cubists often did. On the contrary, we tried to keep as close as possible to the 3-dimensional analog. This means, of course, we had a freedom of choice, for example, for the size of the quadrics and also for the alignment, which is due to the 4th dimension. But we did our extensions only carefully. That means we tried to keep as bold as possible. This means, for example, that we didn't implement another arm or something like that. So in particular, we see Manicone rather as a kind of sketch. The intention behind the sketchiness and the boldness of Manicone, as well as the choice of its humanoid form, was to sharpen perception for the 4-dimensional space. But let's come back to our figure. Here we have a very rough discretization. Nevertheless, we can perform all manipulations just as before in the smooth case, like rotating hyperplanes, rotating in the hyperplane, and so on. And this time we kicked it softly, so the movement is a little bit slower.